Hello to everyone. In this practical work, we will classify a forest area into different field models using LiDAR and multispectral data such as Sentinel-2 and WorldView-2. The required information is stored in different directories. Sentinel-2 and WorldView-2 images are split into different bands and saved in their respective folders. LiDAR data are stored in the LiDAR folder, and the shapefile of the study area is in this folder. The first step consists of generating the digital terrain model, the digital surface model, and the normalized digital surface model using the LiDAR data and the software Fusion. The execution of Fusion commands must be done by writing a script file in BAT format. Therefore, we must open a new text file and write the next commands. The command ground filter requires the G and W parameters, the output file that will contain the ground points, the cell size, taking a value of 5 meters since the LiDAR point density is equal to 0.5 points per square meter, and a text file containing the path of all the input LiDAR files. Once the ground points have been filtered, the digital terrain model can be created using the command grid surface create. The output will be created as a DTM format. The input size corresponds with the ground filter points, and the set of parameters such as the pixel size, the units of the X, Y, and Z axis, and reference system information must be indicated. The output file will have a DTM format, therefore we must convert it to a format that can be opened in QGIS, such as ASCII. For the generation of the digital surface model, we need to execute the command canopy model, indicating the output file, the input file as a text file where the path of the last files are written, and the set of parameters such as the pixel size, X, Y, and Z units, and some reference system parameters. Also, the model must be converted to a format such as ASCII that can be opened in QGIS. Then we save this file as a BAT file. We open the Windows command prompt. We change the directory until be located in the one where the BAT file has been saved. We type the name of the batch file, and we press the Enter key to launch it. Once the digital elevation models have been created, we can load them in QGIS. However, firstly, we must select the reference system of the canvas. The next step consists of calculating the normalized digital surface model as the difference between the digital surface model and the digital terrain model in the raster calculator. We select the output directory and name, and the reference system. Next, we load the study area to clip the normalized digital surface model according to its limits. The next step will be to calculate the NDVI from the corresponding WorldView 2 bands. So we load the bands 5 and 7. And we write the NDVI equation in the raster calculator. Then we select the output directory and name, and the reference system. Then we clip the NDVI image according to the study area limits. The normalized digital surface model and NDVI rasters will be used for the segmentation. However, as these data do not have the same order of magnitude and units, it's necessary to convert them to an equivalent scale. For example, the rasters can be converted to an unsigned integer raster format for segmentation. To do that, we translate each of the rasters indicating the parameter scale and the output format as uint16. We do this for the NDVI image, and then for the normalized digital surface model image. Next, we combine both rasters into the same one, but in different bands. Once the NDVI and normalized digital surface model information have been combined, we can carry out the segmentation procedure using the available tool in the Orfeo toolbox. We select the input raster and the output file name. Then we can visualize the resulting segmentation. There are some big erroneous segments created at the edges. We can edit the shapefile and remove them by using the delete button and save it.